Buenos días. Vamos a iniciar la charla del Fórum UNESCO, titulada, pues, básicamente Construcción y forma en la arquitectura tradicional, la creatividad. Y tenemos al profesor italiano Paolo Vitti, que es doctor arquitecto, profesor en la Facultad de Arquitectura de la Universidad Roma III, en Roma, y de Notre Dame. Y es, bueno, entre sus facetas, es especialista tanto en investigación como en realización de obra, de arquitectura básicamente patrimonial o tradicional, haciendo especial hincapié en la construcción, la relación que hay entre construcción y forma y construcción, llegando pues al detalle constructivo y cómo influye eso en el resultado final, incluso de proyecto, no quedarse únicamente en los conceptos generales de forma, que es a veces el defecto que tenemos en la enseñanza de la arquitectura, de pensar, desarrollar conceptos formales y descuidar un poco la realización material, el detalle constructivo, ¿no? Y además también un tema importante, además de toda actualidad, de rescatar, entre comillas, la arquitectura sostenible que está en el propio ADN, o sea, es de la arquitectura tradicional. Ahora que estamos en arquitectura moderna, volver o incorporar la sostenibilidad, resulta que en la arquitectura tradicional esto se da de por sí. Y valorar ese punto de técnicas sostenibles tradicionales y cómo resuelven pues todo el tema del medio ambiente, pues es uno de los factores importantes que Paolo investiga, trabaja y en estos momentos también da a conocer. Yo por mi parte nada más y os dejo ya con Paolo.
Muchas gracias. Es un honor haber sido invitado por Fernando Vegas y Camila Mileto a esta serie de conferencias de la Cátedra UNESCO del Politécnico de Valencia. Es un placer de presentar mi trabajo, que es esta investigación sobre la relación entre los sistemas constructivos y las formas arquitectónicas. Desafortunadamente voy a hablar en inglés, mi castellano es insuficiente para continuar sin muchas faltas, errores. I will start my talk with this sentence. There is a very famous architect, historian, conservator, the founder of the Faculty of Architecture in Rome, who is Gustavo Giovannoni. And there is this sentence that I find that is very interesting, especially today. The architect has to be, first of all, a builder. Forms must come out from a deep understanding of structures. Doing the opposite, by beginning a conceptual design, a blank elevation is irrational. And the young professional will never redeem from this. This is something to always keep in mind. Today we have many projects that start from the form and then get to the structure, while the right approach is to have an holistic, global view of the project. I hope my English is quite understandable. If there is anything you don't understand, you raise your hand and I will be happy to find the way with Valentina to translate in Spanish. I will start showing this, which is a very simple construction. Here the challenge is dry masonry without mortar. Materials are kept together by a good approach to resist to the forces. And this is a vernacular construction you can find everywhere in the Mediterranean, but also beyond the Mediterranean. In Hellenistic period is to say from 4th to 1st century BC, there is a change in the dimension of construction. And the challenge is to make buildings that are monumental using the principles of dry masonry. Dry masonry, as we said, without bonding material, mortar. This is a typical example is in the island of Rhodes in Greece, where you can see a tower which is made with blocks, ashlars of stone, which are placed dry. Now, one of the wonders of the world was the Lighthouse of Alexandria. I suppose you all know about this building. This building was started in 283 BC, and imagine, this collapsed only in the 14th century AD. That is to say, it's a building that lasted for more than 1600 years, which is amazing for a construction which was monumental and was made out of dry masonry. So here we understand that the architect is facing the challenge of a structural system to transform it to form and architecture. So let's look closer to this project because it may be useful for understanding later architecture. First of all, we don't know. This, since it has collapsed, we have not evidence of it. But we know very well about the architecture through the Arabic descriptions. So the architects coming from El-Andalus, they were traveling to go to Mecca, passing through Alexandria, and in Alexandria they were impressed by this architecture. From these descriptions, we know that this tower, which was more than 110 meters high, had a spiral staircase, a spiral ramp going up to the top, as you can see in this drawing. But most interesting is that the center of this tower, gigantic tower, had a core that was hollow, that is to say empty. This is exceptional considering the concept of Hellenistic architecture, which is based that you want to make it big, then fill it with material. So the big towers will be something that has plenty of material and not a hollow space at the center. The reason for that is that this could be easier to lift materials from during the construction. This was built on the island of Pharos. And Pharos is the name we use for lighthouse in many languages, as in Italian, in Greek, and many other languages, not in English, which is lighthouse. And the tower took the name from the island that it was in Alexandria. And so the empty core of the tower was useful to lift up materials. But it was also useful because in the use you have to, this was also a defense tower, so you had the use. So it was a very clever concept, but it was a challenge. The challenge comes from the fact that a structure, so high structure in the 3rd century BC, typically would have been built with a core which was filled with material in order to be enough high. So here the concept is extraordinary, is innovative, is a way to face not only, let's say, the construction issues, but also the functional issues. Imagine that this construction is built, there is a ramp. This ramp is used by the masons to go up, and the material is lifted from the core and placed all around. So the tower grows and goes up. Imagine to do the same thing with a scaffolding, exterior scaffolding. It will be very costly, you need a lot of wood, but most of all you are on an island. And so this poses many problems. But where the form comes out, because the form of this tower is composed by two elements. You have a lower sector, which is made with a square construction, and then you have the upper part with an octagonal. We know that from the sources. It's very clear. The fact is that the octagonal tower had to be very high as 100 meters. But in order to resist and to become stronger, the builders imagined to buttress this tower in the lower part. You see the red vertical lines. The red vertical lines are the ones which show this buttressing structure. So the form was generated from a concept, a structural concept. Another very interesting element is that, as we know, under the Almohad dynasty, they started to be gigantic minarets. The first one of these is the Kutubiyya in Marrakesh. These minarets have many elements in common with the Lighthouse of Alexandria. The Kutubiyya was built in 1157. Then comes the Giralda, you know very well, in Sevilla. It's slightly later. And then the last of them is the Tur Hassan in Rabat. This, as you see here, I show the ratio between the base of the tower and the height. And then you have the Lighthouse of Alexandria, which, if you consider only the octagonal tower, you have 1 to 35, but if you consider only, it becomes more slender if you remove the buttressing part. This is to say that there are similarities, but the most important element is that we have a description, the most precise description we have from the Lighthouse of Alexandria comes from this architect who was from Malaga, who gave the most precise description of this lighthouse. And we are, as you see, exactly in the period where the minarets, these gigantic minarets, were built. So I strongly believe that these minarets were inspired by the structural concept of the Lighthouse of Alexandria. This hypothesis is supported by the fact that the three minarets, they have, the three of them, a spiral ramp which goes up to the top. Actually, this is supported also by the description of Idrisi. To climb the lighthouse, there is a wide staircase like the towers of the mosques. Moreover, in the three minarets, at the center, we have rooms which stand one above the other, which under a structural concept is the same as having the halo that you have in the Lighthouse of Alexandria. And of course, all of them have a square base and windows which lit the ramp. So I believe that in the Arabic culture, when they were to invent a new model for this gigantic architecture, they referred to the most impressive gigantic tower there was in antiquity, which was the Tower of Alexandria. Now, let's move on another ground. on a ground that is much more challenging. We pass from a system which is based on the so-called post and lintel, that is to say, the weight is transferred through vertical forces from one stone to the other through the contact. We pass to a system which is the system generated, the structural system generated by arches and vaults. As you know, this generates thrust. Thrust is empuje. So this was something that we all consider that was somehow invented by the Romans. And all the Roman architecture, as we will see, found impressive architectural solutions and structural layouts through the use of arches and vaults. However, it's less known that one of the most impressive monumental vaults is to be found, which is only partially preserved, is to be found in Cyprus, in the island of Cyprus. It's in the archaeological site of Salamis, where you have in one of the so-called royal tombs, you have this mound, and inside the mound we have a very particular structure, which is made above the funeral chamber where the dead was buried. And there was a drum. A drum is tambor, an element which was solid, filled with material, and supporting a dome above. This dome has a span of 9 meters and is made with mud bricks, adobe, and it's made placing the bricks radially. So it's not like a Mycenaean tholos, which is a false vault with elements placed horizontally, but the elements are placed radially. So we could say that this, as far as we know, is the first monumental dome we know in the history of architecture. Above this dome there was the mound, and I will not give more details about this, but the structure is particularly interesting because this dome was not accessible, was a symbolic dome. Then we pass through to the Hellenistic architecture, the Macedonian tombs. They all display these amazing barrel vaults made out of ashlars, of stones, placed radially. And here the architects, to face the challenge of the thrust, the empuje, they place the barrel vaults buried into the ground. So being inside the ground, they don't have to face the challenge of the thrust on the supporting walls. But then we go to the Romans. So the Romans, they started, of course, it's a very long process. They started to use in a massive way the concept of using arches and vaults. Here, what we see here, this is on the Palatine Hill in Rome, is the Domus Augustana, the imperial palace, and we have these octagonal rooms which face the challenge of having these niches all around, which actually are below the massive dome that stands above the niches. And here, for this solution, the architects used a very untypical system for creating the jack arches. Piazza banda, how is in Spanish? See? And they create these elements only with bricks in order to make them stiffer, stronger. So they are thinking. But here you see, in this, from the picture, you understand that the light that gets into this room is very limited. And so you know very well from that architecture is the game of light. So the more you can use light, the more you can make significance the interior space. And we know very well that Roman architecture was revolutionary not only for the engineering and the building techniques, but also for the idea of space, which was generated through the use also of light. In Greek architecture, typically, we consider that is an exterior architecture. In Roman architecture is the interior space which becomes formally extremely important. Here you see, the plan, when you see these brick jack arches. But I will go directly to one of the most impressive, spectacular, revolutionary buildings in Roman architecture, which is the Golden House of Nero. This building is placed in Rome, close to the Colosseum. Actually, is not very much accessible, but has one of the most famous rooms of this building is the so-called Octagonal Room. The Octagonal Room, just look at the picture, at the two pictures, and you see something that is incredible. The vault is supported by pilasters, not by walls. So here, the architects, they really try to challenge the sense of space. If we look at the plan, this is a section and shows the vault and shows how the light comes inside. But let's look to the plan. The plan of the Octagonal Room is like this. So you have the central room, and around the central room, you have radiating rooms. And the connection is between the central room and the radiating rooms. The architect wanted to have a space that was expanding, and to create this, he needed to have light not only in the central room, which is lit from the opening, like the Pantheon, which stands on the top of the vault, but also through the light entering into the side rooms. And he wants to reduce the supporting walls of the dome, the central dome. How to do that? You need two elements. A very extraordinary high-quality construction technique, and second, a very impressive idea of the structural layout. How to achieve that? The idea is very simple. If you look at this section, you see that on the left you have the dome, and on the right you have the rooms, which are lit through this element. You don't have the mouse, I don't have a pointer, but you have, you see on the right of the red vault, you have a window which gives light to the room. So under a point of view of perception, you have light inside the room and outside the room, but you are within a construction. To do that, the architects have created some buttressing wall, buttresses. How you say buttresses in Spanish? Contrafuertes, which are hidden, as you see here, in the red elements, which are hidden around the. Sí, muchas gracias. Okay. These elements are hidden between the windows. This generates something that was extraordinarily innovative in architecture. How to have these immense openings? This is done through the use of concrete. This is concrete means formigón romano, is unreinforced. There is no iron. And these elements are enough strong to divert the forces on the pilasters. In the most compressed part, you have travertine, stone. So they understand how to use the materials, and which is the capacity of resisting of the materials to the stresses. Actually, in vaulting, we have two systems in the Roman times. The first system is the one we know of concrete, formigón, in Rome and in the area of Naples. Rome is known for concrete structures, and the concept is very clear. You have a centering, cimbra, on which you start to lay layers of materials. These layers of materials are made of small stones. Imagine that these stones are as big as my hand, placed on horizontal layers, always horizontal layers, and of course they are bonded with an extremely high qualitative hydraulic mortar, mortero idraulico. The reason for the horizontal layers is very simple, that placing the materials by hand in horizontal layers, you avoid to have voids. At the same moment, you can tamp, you can compress this in order to make it stronger. Then, of course, before removing the centering, the cimbra, you need to have the element to dry and to become kind of monolithic and strong, as that you remove the centering and then the forces are transferred from the vault to the supporting walls. But there is another system, and this system was used not in Rome, but developed in Greece, in the Peloponnese. It's made with the construction of brick vaults. The concept is similar. You need a centering, a cimbra, to place the bricks. And then once you place the key brick at the center, at this moment, the arch starts to work and diverts the forces to the supporting walls. Then you can remove the centering, and at this point, you can build above this the concrete structure, because Romans were thinking with massive structures. So only in later architecture we start to use thin brick vaults. So the reason for that is that the Romans in Greece, they did not have good hydraulic mortar. And so they could not afford to have structures as the ones in Rome. So they invented a system which was through this centering, through this brick vault, which becomes actually a system that once you place the key brick and the pressure is transferred to the arch, then this structure is working because it has very small mortar joints. So this allows you to make quicker and stronger the structure. Imagine that brick vaults are actually one of the most used systems for vaulting in all Europe, and beyond, of course. So this revolution happened in Greece between the end of the 1st century BC and the start of the 1st century AD. But let's go to another impressive building. This building is the Trajan's Markets. Have you ever been to Rome? Some of you? So it's one of the most impressive buildings. You see this vault? This vault is like a sail. Is a concrete structure which has all openings all around. It's located in one of the most renowned parts of the imperial fora in Rome. And the hall, as you can see, is a rectangular hall. And this vault, which is a series of cross vaults, is supported by these piers. So it was a very challenging structure. But here again, the idea of the architect was to have light entering from the windows into the room and have this vault like as less massive, visually speaking, as possible. This was achieved again through an understanding of structural layout and construction solutions. In this drawing, you have a diagram which shows that you have travertine supports in the part that has higher stresses, as in the Golden House. And above this, you have a very particular system of concrete made with bricks, 2 layers, and the upper part is made with concrete with lighter materials. Since the thrust, empuje, is generated by the weight, by reducing the weight, you reduce the thrust. So there is a complete understanding of materials, building techniques, and structural layouts. So we are going through masterpieces of architecture, but these masterpieces are interesting because they teach us how the problems were solved between construction techniques and forms of architecture. The formal part is connected to the construction issues, and sometimes we don't know who is influencing the other. Was the capacity of the Romans to generate an excellent construction technique that made it possible to generate new forms of architecture? Or these new forms of architecture challenged the architects to find technical solutions and building techniques that were up to the level of efforts? We don't know. Possibly there is not a solution in this sense. The study of Roman concrete has displayed that Romans, by the 2nd century AD, they had developed an immense understanding of the quality of concrete, up to the point that we understand today that while modern concrete has a very short span of life, it can last 100 years, Roman concrete, the more gets older, the stronger it gets. So it's an incredible material. And now we are studying today to understand which were the properties of Roman concrete which made it possible to have such an exceptional rock, because we can say it was like a rock. This generated architecture like this. These are the Frigidaria of the imperial bath complexes. This is the Frigidarium of the baths of Diocletian in Rome, which were transformed by Michelangelo and Vanvitelli to Santa Maria degli Angeli. It's a spectacular room where you can see that the dimension of the vault is immense. And again, architects succeeded to have light entering into this hall, so to reduce as much as possible the sense of massiveness of the structure. Seen from outside, you see in the vault below. On the left hand you have the plan, and then you see here that this vault is made possible by the use of these buttressing elements, contrafuertes, which make possible to stand to the thrust generated by this massive and immense cross vault. If you look up on the image on the left, this is something that was inspired in American architecture from Roman imperial architecture. This was the Pennsylvania Station in New York, which was demolished, which had a hall which was directly inspired to the Roman model. But as you can see, there are no buttressing, no contrafuertes. The reason for that is that the vault was not made with concrete, so it was a light vault. And finally, in Greece, you find structures like this, that for the ones who have been in Italy and visited Villa Adriana, there is the famous example of the Caldarium, of the Frigidarium of the Greek Great Baths, which looks similar. Incredible how you can say that a vault can stand like this. The reason for that is that concrete generates immense capacity to resist to stresses, tensile stresses too. But the most interesting element is that in this Roman bath in Greece, we have something that looks very, very particular. And it's the fact that, as you can see in the picture, there are layers of bricks placed horizontally. You can see them in this picture, there. Each 30 centimeters, more or less like this, you have layers of bricks. These layers of bricks, and bricks was used actually by the Romans because it was a material that was very much resistant and excellent, so they were using them as tie elements, as elements of resistance within the concrete structure. We thus are not impressed to see that this concept was adopted also in Rome, in few buildings, but one in particular, in the Pantheon. In the Pantheon, you have, in this position, rings of bipedales, big 60 by 60 bricks, which generates these layers of bricks which are tie elements. But Romans used also iron. And iron, the most renowned example is again in Villa Adriana, Hadrian's Villa, where we have a system of jack arches which are made out of bricks reinforced by iron bars. This is not preserved anymore, but we know that because we have these travertine elements which receive the bars, which show that they were the place for this to anchor these iron bars. But I had the chance to come through one of building in Greece, in Corinth, which preserves still nowadays iron elements in the vault. One of these elements was found by the excavator, the archaeologist Beers, who excavated in the 1960s this bath, and found, as you can see here, in the vault, a bar, an iron bar, which was embedded into concrete. We know now that these iron bars, after the studies of Janet Delane, Carla Amici, Lynn Lancaster, they were used also in other buildings in Rome. But the evidence is possible only in this bath building, because in Rome all the metal elements were reused and taken out in the Middle Ages and were lost. This bar was used in a room that was located here at the center of the baths, and on one side it was facing a courtyard, as you see here. It was facing this courtyard. So on that side here, the vault was placed against, was not buttressed by other adjoining rooms around it. So the architects decided to use iron bars. Likely one of these was placed here on the extrados, as in many other cases. So not as we do at the level of the haunches, Reni, how you say haunches? Los riñones, normally, or at the impost. Here are above. And there were other elements, which are these bars, which were used to hang a counter vault in the hot room. Now, the problem of the thrust can be addressed in many ways. One possibility is to use the solution adopted by Michelangelo for St. Peter. You create in the drum of the dome, under the dome, supporting the dome, you create buttressing elements, which are given a magnificent architectural layout by Michelangelo. Another possibility is the one that was adopted, for instance, in the baptistry of Parma, which is I add a weight which creates a vertical component and makes that the thrust is more vertical, as we can see in this case. Another solution was the one adopted by Brunelleschi. So I make the profile of the vault higher, and in this way I succeed again to have a vertical thrust, in order that, because all these architectures have an element which is particularly powerful for the image itself of the dome, is the fact that they raise on a high drum, so they can be higher and more visible, and they can allow light to enter through the drum inside the church. But there is another solution which is adopted also by Leon Battista Alberti, which is to insert iron rods, but in this case they create an element which is embedded into the masonry and makes it possible to keep stronger the drum, as you can see in this drawing. Sebastiano Serlio was suggesting to use similar bars as used typically by Brunelleschi at the impost of the vaults, in order that you could create a portico. A portico is made out of columns in order to make possible to pass from the courtyard to the portico. So it's a very light structure, but you have, if you cover the structure with a vault, with a cross vault, you need to have iron tie rods to make it stronger. And this was the solution that was suggested by Serlio, and having the metal elements visible. Borromini wanted to go beyond that. In his famous portico cloister of San Carlino alle Quattro Fontane, he creates a model which is very similar to the one of Serlio, but not metal tie rods visible. So how it stands? Well, they are hidden. They are hidden This is a sketch we know from Borromini. He hides with a very, let's say, elaborate system, as you see, in a way that the bars, instead of being here, they are hidden in that way. Another masterpiece, Sant'Agnese in Piazza Navona, Rome. We all admire this impressive church for the drum and the cupola, which stand just above the facade. It could be the result of the idea of Raphael for the new St. Peter to have a cross church with a dome, so to have the cupola, the dome, just above the facade. It's interesting to notice that the project, the original project, which was made by Rainaldi, was intended to be without the drum, because the drum would have challenged the thrust generated by the vault. When the project passed to Borromini, Borromini created the drum and raised up the dome. And